Hey folks, today I have the pleasure to host for the first time Matthew Delia. He's a solution architect based in the US, and today he gonna demo a very interesting feature that will help a lot of people in the healthcare vertical. Hey Matthew, how are you doing?
Good, Yosef. How you doing? Good to see you.
Good to see you too. I'm very happy to have you here. We discussed about making this video a few months ago, and he's like built a massive or awesome demo that will show about how to leverage a FHIR format using Databricks technology such as Lakeflow and much more. So can you, Matthew, tell us a bit more about this FHIR format and how we can leverage it?
In healthcare, where I get to work here at Databricks, a lot of experience as a customer before that, working for health insurance here in the United States. You have to be able to share data with all these different components of the healthcare system, right? So providers have to send data to payers or to other providers. Payers, of course, are trying to, potentially co-manage the members for things like value-based payment or HEDIS, risk adjustment, all these sort of things that we have to do. Whether it's a mandate, that's coming from the government, or it's just, better for patient outcome if, folks can share data. So there's been many attempts to do this in a easy way over the years. And there's a group called HL7 that comes out with these specifications for folks to use in order to share this data. We call this interoperability on the healthcare space. And there's been a few, I would call them like almost like false starts, sort of in a way. HL7 V2, I don't even remember what a V1 looked like, to be candid, but V2, sort of a transaction based, sort of within those transactions, multiple lines, if you can kind of picture that. It would be both like a delimiter within a delimiter. It's like pipe delimited with, also commas and tildes. It was very complicated to use those in reality. And then, people switched to XML. And all of these are still in use, by the way, because once you start with one of these formats, it's hard to break away. People build applications on top of them. XML is notoriously difficult to work with, as many people know. So kind of the most recent one that has really kind of taken off, caught fire, so to speak, is the Fast Healthcare Interoperability Resources, and that is FHIR, FHIR. And that's a JSON format, which makes it a lot easier to be able to share this data. Now, if you are in the healthcare space, here, especially here in the United States, but really worldwide, being able to receive clinical data in a way that you can ingest that and make sense of it, it really opens up all of the different use cases that a healthcare organization cares about, such as, being able to look at clinical notes and use those for maybe a vector store, and then something like agent bricks later to extract value out of those and identify patterns there. So predicting adverse events, understanding your patient population, quality measures, all the sort of things that that the folks in the healthcare space really care about. It's all really locked away in this data. So these JSON files is what the FHIR format is. It's already better than XML, but they're extremely nested. They're actually also very large, and no two of them really have the same format. There are certain rules for how you put them together. I'll show you one in a second, just to kind of scare you, kind of what we deal with here in the healthcare space. But they've actually also been sort of notoriously difficult to take apart as well, to use for analytics. They're great for, JSON's always been great for sending information someplace else, but not really great for turning it into a data model so that you can do all the kind of things that, folks actually want to use this data for. So, let me share my screen. Let me kind of show you the motivation here for what we ended up doing. And to be candid, previously, before we had some new advancements in Databricks, and even doing this in Spark previously, would have required either accelerators like DB Ignite, which we had produced, here in Databricks in our industry solutions, or other specialized software in order to take these FHIR bundles apart. You're going to hear me say file, JSON file, bundle. When we talk about FHIR, uh, often we call it a bundle because it's essentially packaging together these different, what we call resources. And a resource is going to be information that's going to tie together. It's essentially like its own data model within this JSON that all relates to a patient or an encounter. An encounter might be you go to the office, have an office visit with a doctor. That's an encounter. Or it might be an observation. you go and have a lab blood draw of some sort, and your glucose value is going to be an observation, let's say, or a diagnostic report. There's going to be these clinical notes, all of this kind of great stuff. And there's about 187 or so about these different resources. Here's what one looks like, right? So you can see this one's and this is
Prettiness.
synthetic data, by the way, that we'll be able to share with the customer. And we got the resource type bundle here. It's a transaction type. And then all the magic happens in this entry array. And this is what kind of makes it difficult. In the entry array, you have something called the full URL. And that's basically the primary key for that particular resource in the array. It happens to live next to the actual data that you need it. This is synthetic data. And when you use synthetic data, often you make it a little bit nicer to work with. So you can see that there is an ID here, and that, happens to match part of this full URL, which is really nice. In the real world, that's not a requirement. Even just capturing the full URL next to the actual real data can be a challenge just using like normal tools. And you can see here, this is a patient resource type. It's JSON. So, the order is nice here because it's synthetic. And again, in the real world, the order could be anything. And there's these things called extensions, which you can see. This makes it very extensible, of course, but that also produces a challenge often because you can see you can have an extension of an extension, and that can go very deep and nested. So even if you try to make a schema for these types of things, often it breaks after a while, and you just end up with some string values at the very end because no one really is ever going to know for a particular transaction how many nested of these extensions you might have. And then additionally, because this array, this entry array starts with patient, but then you could have all these different encounters. You can see how gigantic this is here. All these different encounters, right? And an encounter has providers. There could be more than one, locations, all these different things. The structure of any two of these could be wildly different. So there's really not like a universal schema for all of these. There's sometimes just a universal schema for potentially a resource in the middle. And folks have come up with kind of interesting ways to parse these, such as like cutting the files up and everything. But, these full URLs, which are basically the primary keys and foreign keys to join these things together, they're really just very unique to this file itself. And by splitting it up, you may actually be causing like a data quality issues. But being able to ingest these easily, usually in a streaming or real-time kind of way, is critically important because this is the kind of information that could be used for that real-time decision making that maybe really would affect a patient's care. So that's sort of the motivation here, is that they're difficult to work with, great for sending, hard to actually get value. Use them for analytics, machine learning, all the kind of great stuff that we want to use it.
I'd be curious to know how people used to leverage this in the past.
Past, really the only game in town was actually something we had also produced at Databricks in the past called DB Ignite. That's still a great industry solution package. It's available completely open source for all of our customers on GitHub. So you can use it, and a lot of folks do use it in production today in order to parse these. And that required some very sophisticated custom Spark functions in order to actually parse this and make sense of it. But depending on the real world situation you might be in, something like those full URLs, if they were required, some of those other types of these packages, even ours, like didn't necessarily know to, keep that along for the ride and bring that in. It also, to be candid, having come out a few years ago, it, relies on things like RDDs. You have to have a classic compute cluster, those sort of things. And, I really want to make sure that our customers are able to do things as easy as they possibly can. And sometimes that just means that the great innovation that we do here at Databricks allows us to make things a lot simpler. So two things that have really happened that have made this something where you don't need a specialized software or even an accelerator from us is Lakeflow declarative pipelines, especially being able to do those with SQL on serverless SQL, right? So even for folks that maybe even the pipeline interface itself is maybe a little too scary, but they know how to write SQL and they're connected to a serverless SQL warehouse, you can actually, generate those right now using the SQL syntax. So I typically show that. And then also just variant, right? So the data type variant, which is, as of speaking right now with you, is technically public preview in both Delta and Iceberg. Previously, you would have had to use a specialized software, including an accelerator from Databricks, DB which is available open source on our GitHub and Databricks Industry Solutions. Still widely used in production by many organizations, and it does more than just ingest FHIR JSONs. I'll mention it's also fantastic with a low code sort of mapping for actually writing JSON bundles, because ultimately, let's say you make a machine learning model that probably predicts the probability that somebody may have developed sepsis, or may not see a behavioral health specialist upon discharge from a BH inpatient admission. You want to get that information over to somebody who can act on it as soon as possible. And often the way that you would send that into an electronic medical record system like an Epic or a Cerner is by generating a FHIR bundle and sending it over. So DB Ignite is still kind of one of the only things that can do that really easily from your Lakehouse data using Spark. But you don't technically need it any longer with ingestion, because we continue to innovate here at Databricks. It's really exciting. So two things really happened that allowed us to make this easier than ever before, right? Such that any SQL analyst can actually pick this up and understand this, right? So something that used to be really hard, accelerators or specialized software, some of which are actually leaving the industry. If you follow this, I won't say who, but now a SQL analyst can do this. So let me kind of explain how that happened, right? So two things. One is that with Lakeflow declarative pipelines, things that used to be really hard, like creating streaming tables, incremental materialized views, those sort of things, you can now write them with the SQL language, and you can actually execute them directly against the serverless SQL warehouses, even if something like the Lakeflow declarative pipelines, multi-file editors, too complicated for whatever reason.
And they can
So
also
that's
use
really cool.
Designer.
Go ahead.
Maybe in the future, they can also use a Lakeflow Designer where they can just do the
That's
drag.
right.
And it's part of what you mentioned, like democratizing access data to everyone. So what used to be hard to process, now it's way easier.
Yeah, 100%. 100%. And the second thing, to be candid, is that, in Delta Lake, technically in public preview right now, the new variant data type, which allows you to take things like these JSON files, have no knowledge of the schema, and start to immediately parse them. And, we call it variant because sometimes you just don't have control over, what the schema might be, right? That, typically we like to think about JSON coming back from APIs, for example. And today, maybe it's one schema that, the API provider decides, and tomorrow it's a different one, right? And, in order to be able to allow that to not break our system, even though we do offer things like schema evolution and Lakeflow declarative pipelines, it allows you to really easily, take that, ingest it, use it. And I'll show a few different things here that we're able to do with the try parse JSON function, which lets us turn something that's complicated like this into something we can write SQL against. So let's go ahead and do that. So I'm going to switch over here to Databricks, of course. And what I've got here is I've loaded several of these JSONs. Again, this is all synthetic data we generated from Syntheia. There's a great repo that I have on my GitHub that allows you to run Syntheia directly on Databricks. So we'll pass that along later for folks. So if you're somebody that wants to play with this, you'll be able to either use a few files that we'll provide, or you can actually generate your own data, which really makes it even more real, which is really cool. So you can see that a lot of this I've generated several months ago, but I do this demo all the time. In the volume itself, we can actually click and see these. So here's one of those exact JSON files. Of course, it is gigantic, and that is what we're going to load. So we have a workflow that I often kick off during my demos. First time I did this was actually for a webinar back in early January. Every few weeks or every few days, or whatever it might be, somebody will ask me, can you do this demo live? And we'll often generate new files directly to that volume. And you can see that, I've got a file arrival trigger here, for example, that will kick this workflow off. And what's really cool about this workflow, and I actually just ran it manually, I think just a few minutes ago here, just to kind of do this, is these are actually SQL notebook tasks, SQL notebooks that are executing against a serverless SQL warehouse. So again, just for that kind of democratization, Joseph, that we were sort of talking about a few minutes ago. If I was to put this in production in, reality, I probably would add this to, maybe a Lakeflow declarative pipeline with the multi-file editor and, kind of add some additional bells and whistles that we can get with that. Um, from just like a teaching perspective, I really like using SQL notebooks and being able to show people that like, hey, you can do really interesting things just with serverless SQL, right? So even without even using other types of compute. So, I declare some variables and things like that you can see here. A lot of folks sometimes don't even know that you can do this, that you can declare variables directly in SQL. And then for things like the schema or the catalog, you can use the identifier a function here, and that will actually take things that are, in the namespace in Unity catalog and allow them to be executed as variables in your code, which this makes it, completely able to be used in an asset bundle or something like that for CI/CD. Of course, you probably have a catalog or a schema for the different environment variables and things like that. And one of the things I like to do is declare statements that maybe I want to execute by sort of building them together and as a string, and then you can execute those immediately. I mean, this is something that actually has been in Databricks SQL for over a year now. You did not need to wait for the stored procedures preview for this to even happen. This is something that we've actually had for quite a while.
And
So
just
you can
for your
see,
information, we will put the documentation for all the features that Matthew will mention, the identifier, the execute immediate, so you know why to use them and also when to use them. And in addition, all the code that Matthew will be showing will be available in the description of this video. It will be in GitHub, and then you can deploy this pipeline on your own platform or even Databricks free edition.
that's right. So let's get down to it, right? So, here's the files. Again, we're just, I just did a list statement just to show that they're here, right? Of course. So the only thing that is really of interest here that I had to create, sort of a statement that's going to be executed is that, the volume path is going to be different depending on what catalog or schema maybe I've chosen. Otherwise, this code, I could have just hard coded this if I knew it, but exactly. But again, I always like to think of things for deployable in your environment also. So, you get to choose your catalog and your schema, and then this volume path will automatically be there. But if we look at the SQL, create or refresh streaming table, again, not PySpark, not Scala, not Spark structured streaming. This is just going to automatically take care of this for us using Lakeflow declarative pipelines, which is really exciting. And I can apply DDL just like I might have, normally when I was doing something like in a traditional warehouse. And I could even do things like, have a default with the current timestamp. And this first table here, I'm going to use autoloader and I'm going to stream using the read files function. And notice what I'm doing here is I'm just going to load this in first as text, and that will just create a string representation of each of those JSON files. And this will allow me to then, kind of have a couple things here. I'm going to bring in things like the file metadata, so I know exactly, where that file lived originally. That's actually really important, Yosef, from a healthcare perspective. If I act on some information, maybe from a machine learning model on a Medicare member here in the United States, I might have to, in an audit, prove like exactly where all of that came from. So like right from where, the output from the machine learning model to the features, to the tables, all the way back to the file. So I could say, this is exactly where that came from. And this is why I acted on that. And I might need to know that for 11 years, believe it or not, based on some of the requirements that we have here in the United States. Just a few other things here, like table properties that I like to set and so forth. And, I'm building this statement here, as you can see. So I always like to print those using a select, which is really cool. And then there's that execute immediate, which then behind the scenes created that Lakeflow declarative pipeline for me just for that one streaming table and allows me to, ingest that in really easily. And
And you
again, that's SQL. You could put that in an actual Lakeflow declarative pipeline with the multi-file editor, and it would function exactly the same, which is pretty cool. This is what you get. I have this kind of opinionated way of doing my bronze tables. Here's my file metadata as a struct, which of course is great. It also is going to be used potentially for a slowly changing dimension type 1 or type 2 later when I want to create my silver tables. I might not have any other information about changes to an encounter or a clinical note or something like that, other than this file is newer than a previous file where I received that, that other information. So something like the file modification time, when this file was created, those sort of things, that is often going to be pretty important to carry through. So sometimes you need this file metadata, even just to kind of make sense of it later downstream. I always like to do the ingest time and things. And, here's just that value, the string value representation of this from a mandate perspective in the United
Big
States.
one.
Sometimes people are like, well, we just needed to get it in. And usually when I, show this to folks in the industry, it's like, oh, we met the mandate. There it is. And usually people laugh because sometimes that's as best as you could have done. But now we get to use the power of Databricks SQL, Lakeflow to Kyoto pipelines, and Variant. So right here, because this is streaming from a previous bronze table, it's just straight SQL. I don't have to actually, parse that together in any way. Again, I can add my metadata or my DDL, I'm sorry, for this here in the table. And then, temporarily, this is really the only option that is really required to use Variant. You actually do not need the pipelines channel preview any longer. This was just, I did this a year ago, I believe, and at the time that was true. But the Variant data type preview in Delta Lake is still true as of, us talking right now. I'd love to update that. Maybe you could update the group in a few weeks when that is going to be GA. I know a lot of folks are interested in that. So in order to just take something like that string value you saw a second ago, and I only printed one record because the data is so large, I can't possibly show more in a notebook. It's all definitely there. But all you need to do is just say, from stream here, again, this is another streaming table, and then just try parse JSON. And there's actually two functions for this. There's parse JSON and try parse JSON. With parse JSON, if you get a malformed JSON, it will actually fail the load because it's expecting, well-formed JSONs, right? The fact that we have to have a term for malformed JSON just means it's, that happens in the real world, of course. So what try parse JSON will do is if it is a malformed one, it'll just create a null. Now, there's maybe one other reason for folks to potentially know about here is that as of today, the maximum size that you can store it for a variant data value in Delta Lake today, this might change in the future, but for today is approximately 16 megabytes. It's actually 16 mebytes, but that's essentially 16 megabytes. So that's per value, not for the whole column, of course. So if you've got exceptionally large, FHIR bundles, for example, which some folks have ones that are much larger than the 16 maybe, then you still can use the try parse JSON and start to extract additional data out of it, like we might if we were using an API call or something like that. But you can't actually, it'll show a null if you, try to take something that's like really, really, really large. So that's another reason potentially to, check things with the file metadata. For the synthetic data that we're using here, that's not really an issue. So we can, kind of move on. So here's what it looks like after you're done, right? So again, same sort of metadata that I'm bringing in here for the file. And this is one of those files that we just ingested here. And let's see what this one looks like. So this one has a meta object here. So I can actually now write SQL against any element of this and start to, kind of take that apart, which is sort of amazing. And so that's the meta object. Here's that entry array. This one looks like it's got 9 elements in here, and of course with the here. So this one looks like it is a message header. And this one is an encounter, and you can see like the encounter has a subject. This would be the patient's full URL. So that's the foreign key to join to the patient and those sort of things. You can see the type there. Even writing SQL against this, you can absolutely do it, which is amazing. One thing that I like to show, and maybe we'll show it in a couple minutes here, is like the latitude and longitude of the patient's address is often buried several layers deep in these types of resources. Let me see if this one maybe doesn't have it exactly, but or maybe it could be here in the extension. Let's see if well, you can see actually there's some good stuff here in the extension for what we call NCQA reporting. We often need to know things like race and ethnicity and those types of things, so we can report out, make sure that our care management programs or whatever don't have any bias or things like that in it. This could be really important data for HEDIS or other types of things. And, that's in the patient resource, but it's, in these extensions, for example. So, you know, being able to extract this sort of information just using SQL is really cool. Let me kind of switch over now to,
You're switching for those
yeah.
who heard Matthew talking about latitude and longitude. Keep in mind that with Databricks SQL, you can also leverage geospatial data and you can maybe create a map where to locate those patients, maybe look for the closest medical center in addition to what Matthew showed.
So let's maybe take a look at that, right? Should start here. So here's that same bronze table, right? And the way that you can actually extract data directly from one of these columns, right? So here's that FHIR metadata is first you select the column just like you normally would in SQL. And then you use a colon. And the colon says like, look, this is variant data. I want to be able to, you know, enter the variant column. Unfortunately, now I'm going to grab the entry array that's part of this. That's where all the meat is. But, that's the colon allows you to go into this. And then, this is an array. And this particular, one that maybe I'm grabbing here happens to be where the patient resource was first. And I happen to know that, you know, that's something we'll address in a second here. But so I'm going to grab the array position of the 0 there. And then if we get into that, then we can see that, that for example, let's go into one of these, the resource, and then you start to use the dot notation like you might have already done previously with JSON, where it's the resource, then the ID. And the thing about variant is that what's interesting about it is that it just assumes that everything should just be the variant data type just to make it so that it kind of, passes or parses easily. In order to do things like comparisons or in order to do things like make a map, for example, which is what we're going to do in a second, you do need to cast it to the actual data type that it should be. Now, we do have some other really cool functions in Databricks SQL, like schema of variant and schema of variant aggregation, which I both love. The difference is that with schema of variant ag or aggregation, you can actually create a universal struct mapping for a particular variant column that you may be looking at that will basically look at all of the different grouping variables and say, this is the kind of structure that will allow for any of the data that you'd seen come in. Because as we know with JSON, especially when we're talking about those API developers, they like to nulls, they like to just, miss them or whatever. So if I only looked at one value, I'd potentially miss other data points that maybe could be there. So looking at lots of the data points and doing that schema of variant aggregation, allows me to kind of get that universal sort of schema. In this case, a lot of folks don't know this, but you can actually cast really nicely in SQL with just the colon. I love this. It's just so much cleaner, especially when you're using this kind of data. It's like, look, I want to grab this resource ID here. When it's the patient resource, that's the patient ID. I'm going to cast that as a string. And then right here in the extension, that's a double. I'm going to cast that as the latitude and the longitude. And then, what you end up with is essentially, something that looks like this, right? So I was able to get down to that really easily. So let me just I'll just add a little where statement here for the first SQL up here, just so we can see what one of those looks like. Let's run that again. And here is just that resource type. Let me bring this down. So, in reality, how did I know that? Like, this is the patient resource. Here's the address. We're just going to assume that the first address in the array is the primary address, really no other way to know that. And then we can get into the extension and then the extension and then the extension. You can see that at some point that might have been string, even if you got a schema from the HL7 website. And then here's the latitude and longitude, right? So, first part of the array is latitude, second part of the array is longitude. Once you have that, you can essentially write that SQL you saw and you can make a map. So we'll go ahead and do this. We'll click on visualization and then I will find map markers. This actually uses Leaflet behind the scenes. I used to be a very proficient R programmer, Yosef, back when I was a data scientist as a customer. And we used to make so many of these leaflet maps that at one time people thought data science meant the cartography team. So I can just click save on there. And now I can kind of just drill in here and have this map really easily. I don't have to code that anymore. I love that.
That's what literally like a few seconds ago. That's amazing.
Yeah. Yeah. So I love that. And, these JSONs can get really complicated. So I actually had a customer send me one. This is going to be a nested bundle. That FHIR bundle that you saw, those ones that you saw, they're already very, really complicated, right? So like making it even more complicated, it just seems mean somehow. What happened is a customer that we work with in healthcare, they messaged me and said, or they messaged their account team who came to me and said, like, look, like we got a customer who's doing some stuff and like none of the software accelerators that they're using work. Can you help them? And I said, sure. So without even looking at the file, I just threw it into my workflow that you saw a few minutes ago, and it completely parsed everything. And then later, I went to look at this using just the SQL editor here. Those FHIR JSONs, right? They're already pretty complicated. So that full workflow that you saw, that'll actually take all those different resources and turn them into silver tables eventually. And we've got a webinar for that. I actually got to speak at Summit where we got to meet Yosef on this and show that as well. So we'll pass on the Summit talk with a great partner of ours called Redox that we also use here. But sometimes people have things that are sort of interesting, right? So a different account team here at Databricks actually contacted me. They said their customer had a really interesting FHIR bundle that none of the other accelerators or other specialized software were able to use it with. And they said they saw your Summit talk. Like, do you think that you can help them with this file? So I said, sure. So they sent me the file. It's fake data or synthetic data also. And I just threw it in that workflow and just had it go through and just, have it ingest it into the bronze and all the silver tables. And I didn't even open the file. I was just so confident that the workflow would work perfectly. So then the morning of the meeting, I went and, started to write some SQL. So I figured I'd switch over to the SQL editor just because sometimes we focus a lot on notebooks and the SQL editor is really, pretty awesome too with the new SQL editor. And I thought, let me just go ahead and start to explore this. Why do they think it was so hard, right? So it turned out that this particular JSON is actually a FHIR bundle that has nested FHIR bundles. So just take what I just showed you and then make it exponentially worse somehow. So you can see that most of the specialized software very likely would not have, very likely not have even considered that was the case. And when I first saw this, I didn't even think it could be possible either. But it turns out that the bundle itself is a resource type. Therefore, you can have it be part of the entry array. So this one's actually kind of interesting. So I'm going to go ahead and again, in the SQL editor, as long as you separate stuff with semicolons, you can declare some variables and kind of chain some stuff together here. So I'm just going to go ahead and do that, make sure I've got the right catalog and schema here using my input parameters that you can see with the colons there. And let's go ahead and look at this particular one specifically. So, knowing the file name, I was able to just kind of filter on the file metadata, of course. So there's that particular file. And, here's the value of this one, just a string. And, you can see it's quite complicated, including the fact that it's actually a bundle within, two bundles actually next to each other inside this bundle. So then we can look at it now with variant, of course, because I brought it through my workflow. And now we can see in the entry array, here's that first one there, and here is the second one. And they are actually, this itself is another bundle. So we can look here, and this is going to then have, all these different things as well. And then we've got another bundle here, and this just gets, more and more complicated as you go down. So how do we want to extract the information out of here? And this actually is for something they want to do explicitly. I actually happen to really I wanted to kind of prove that you can go from just the bronze all the way down to the thing that they were looking for. And this also is just kind of my exploratory analysis in a way too. So, first is you can actually explode these using the lateral variant explode. And what's cool about this is that it will actually group all of the things that you have before the variant column such that it'll explode it long without having to, kind of create any views. And I've actually found, to be candid, that SQL is a lot easier for this than PySpark. And even when I'm coding Lakeflow declarative pipelines with a mix of the languages, I'll often switch to SQL, from in the from statements here. And You might also notice that I'm a big fan of the pipe syntax SQL, which comes from my R days and using dplyr and things like that. So so right here, I'm going to do a with statement. So we're going to basically take that there, and then we're just going to vary and explode. So I just want to show you what that looks like here. And this is how you start to break these things apart. So now I've got essentially the entry, the ID, the meta, the resource type here, right? And now I can start to, see, I start to, write SQL a little bit easier here. I could start to filter that. So then we could pull out, bundle level details, for example. So that's the same exact sort of with statements here or CTEs. And then, I can use this to pivot. So I can pivot on those keys. In the workflow that I show, we actually identify those keys and sort of have it be automatic, so that you can, have it be really generalized, which is cool. And so I'll show you this one now. So now we've pivoted, and now I've got my columns, for example, for these things, right? So, and then I can continue to split this up more and more. So I'll click this off here, and we'll do the next one. And you can see here, you can just keep going and just get more and more interesting here. And we're going to pull out things like that, those full URLs. We're going to explode the entry, which is all the really great information, pull out the full URLs, pull out those things that should be at that kind of the header there. And, again, we're just kind of getting, closer and closer and closer to being able to start to really evaluate, what's going on here. So this one has a full URL. These two don't. And that's because these have the resource types of bundles, right? So now I can see that this is a bundle itself, and so is the other ones. So now I've got to do a second pass, basically, on here, for example. So and then ultimately, this is actually used for what we call electronic clinical quality measures, believe it or not. So after I won't go through all this SQL, but you could see you kind of keep exploding and keep making these CTEs off of here. And, ultimately I can get down to actually showing, what this report will look like. And one of the nice things, of course, of the new SQL editor is you can, click back and forth on the results. And ultimately we needed all of that, giant file was to get down to basically this, where you have the actual information you really care about, like which codes were contained for which observations or whatever were used for the HEDIS measure or the quality measure that's in here, what the evaluated resources are. So these can all join back. So you have like provenance all the way going back. And, the measure date, the measure string, the period start and ends, the measure report, and then, what the, actual subject for that measure is. So, we're able to get down to exactly this one row is what was needed. And then you could see that you could actually use additional things to kind of break this up to know, for the different, groups and things like that would be here for the population and the scores and all this other kind of good stuff here. Um, that's really the power here, is like you can literally take anything and start to break it apart, really easily. And
Now
then
you
I think I'll just show maybe one more thing.
And I think you also make the file, let's say, more readable and accessible to do the aggregation rather than the first one with the I don't know how many nested columns I've seen. So it makes things easier, and you did start breaking it down step by step, like going from many files to one file to many files, then going down until you're able to exploit the data you have inside those formats. This format.
Yeah, it's exactly right. I mean, these files can be wild. So I want to show, just one more thing. You're gonna often create. You're often going to be, pulling things against APIs. And one of the things I love about Databricks Unity Catalog, especially, is you can have an HTTPS external location. So you get lineage and access control lists for all those kind of things. But then you can take that kind of stuff and you can wrap it in, SQL UDFs to make either, table value functions or, just regular user defined functions, which then are also in Unity Catalog for use for lineage and everything. And anyone who connects to a SQL warehouse, a serverless SQL warehouse, can also take advantage of those functions that people create, including, things that are downstream of Databricks like Power BI or something like that. Right. So, but, when you use these APIs, they often come back as JSON, right? So how do you turn it into something that's like table usable? So like in this case, if I just do this right here, let's see if I can,
Yeah,
so
find the
what I'm
right.
going to do here is I'm just going to create, a post. I'm going to basically feed some data into a SQL UDF that I've created called Redux request here. That's going to need, that's going to need the method and what I want to grab. In this case, I'm going to grab a diagnostic report. I want to search for a certain patient, which hopefully is still there. And I'm going to get some sort of response, right? So I'm going to feed those things into this function here, Redux request. That's going to give me JSON back. But I can do this try parse JSON on that and then get variant data back, which from there I can start to actually extract just like I would, normally, just like you saw a few minutes ago, in order to get things like, that full URL, the codes, the encounters, whatever it might be that's associated with this diagnostic report. The example here, the use case here, Yosef, is like, I may be a care manager or utilization management, person at a payer. And I just need to see, are there any like recent lab values? And instead of going and asking a provider for a fax copy of a PDF, maybe I just want to get the PDF itself just directly from the EMR, assuming I've got that ability. This is what this particular thing is able to do. So this diagnostic report, when it comes back technically as a base 64 string. That's just part of the JSON, of course, because you're not going to get, the full text or whatever it might be. So, while it's coming back, like, without having to go and look at that JSON again, and I could wrap this in a table valued function and use it, just have it be in Unity catalog. I'm going to unbase 64 that string and call it diagnostic report. So this is what comes back, right? So I've got those full URLs that I was talking about before. These different codings here. So this is some sort of EEG, the diagnostic report ID that lives somewhere. If this was associated with an encounter, I'd have that foreign key for that. This is null for whatever reason. I've got some metadata, and then check out what I've got here. So this is test data from a test database someplace. So it's not going to be real at all, but you'll notice here that there's this text, rich text format. Well, when it's just regular text, now I've got the text, right? So this is something I can now extract out of here, throw into a vector store index, do some RAG on it potentially, right? And summarize this for whoever might be looking at it, using like AI query, for example. But then I love this. This says application PDF here. This is the binary for making the PDF, which we could then take this in a different workflow and just do a Spark write binary to a volume and like literally have the PDF that then could be surfaced in a Databricks app or, whatever it might be, such that, somebody actually can view the actual PDF and see exactly what it is. So, in the United States, I don't know what it is like in the rest of the world, but like fax machines are HIPAA compliant. So a lot of healthcare professionals are printing stuff, going to a fax machine, faxing it, and then they're hoping that another healthcare professional picks it up in the office and your information is not being shared. I'd much rather have those PDFs just be, automatically sent in something like a HL7 transaction like these with FHIR. And then with Databricks, because we're able to do this, we can just render this PDF and now you've got that PDF on your side that you don't have to then take the fax and then scan it so you can get it into your application. This could just be part of your application now. So this is kind of the start of something, just to kind of show the value. But in production, we would, of course, wrap these with those Unity catalog UDFs, like I mentioned, and, do the other parts of the workflow, for example, that you saw. And then, I like to do other things with Variant too. This is a Kafka stream that I'm bringing in here from Red Panda, actually, and I bring it in. Of course, this is, of course, using our new Lakeflow declarative pipelines. Forgot that the compute turns itself off. It is serverless after all, so that makes sense. So the bronze table is going to have just a JSON payload as the string, as most folks are familiar with when they get Kafka data out. And with Lakeflow declarative pipelines, you can really easily perform slowly changing dimension type 1 and type 2 things just by declaring, for example, a streaming table or maybe a quarantine table based on some sort of expectation where maybe we want to drop that. And then you can define a flow. So in this case, I'm defining a flow here called profiles CDC. So I'm bringing that JSON in, right? I want to be able to parse that so I can apply my auto CDC and create my silver table. Notice right here, what I'm doing is from the streaming, change data feed that's coming in from the bronze table. I'm using try parse JSON and then automatically taking all of those elements out such that I can then easily apply my changes, using this one happens to be a slowly changing dimension type one, just directly to my silver table. So I use this variant in many places. And you'll notice that here, I don't actually store it as variant. So for folks that are, maybe concerned that it's, public preview this week while we're still talking, you don't actually have to store your data as variant to take advantage of using it. In this case, I'm never actually storing it in the Delta table that way. I'm just using the power of variant in memory in my Lakeflow declarative pipeline to take that JSON and parse it and turn it into, these tables that you see down.
That's amazing. So basically, you're leveraging the power of LDP. Plus, of course, I can see the SCD. You can use it easily in like one line of code in Lakeflow declarative pipeline rather than having to code it, which can it can be time consuming. You leverage the power of variant to explode and make those nested, super nested files and make good usage of them to make sure that your I can't call it semi-structured because it's not even structured. Like transforming those semi-structured data to a structured one, which can be which can be queried by analysts and make sure that they can aggregate the KPI and probably save lives. And this is really the power of, I think, not only Matthew's knowledge, but also Databricks features. And when you combine the human plus those awesome features, you can only get awesome projects, which can, and this is really the beauty of using data to transform it into actions. And by actions here, it's very critical saving lives. And I think Matthew, you're gonna share your repo so people can deploy the same code. And if they have any question, if you have any question, make sure to reach out to Matthew. He'll be super happy to help you.
Yeah, thanks for having me. This is it's a real pleasure to get to speak with you and to all of the folks that subscribe to Next Gen Lakehouse. I've been a huge fan for many years.
Thank you.
Thanks.
Thank
Yeah,
you, Matthew. Thank you.
have a good rest.